Hello everyone, I'm Anupma. Welcome to the Ashnik Google Hangout session. We are open solutions provider present across Southeast Asia, UK, US and India. We provide services, consultancy and implementation support for Postgres SQL and other open source technologies. I would like you to let you know that as a part of our regular Hangout session, this time we bring to you an insight on how we can build an available and scalable cluster on Postgres. This session will be delivered to you by our senior database architect Samir. Hope you all have a wonderful session. Please don't forget to submit your questions. We'll be helping you with all your queries. Over to you, Samir.
Thanks a lot, Anupama. Hello, everyone, and I'm going to share my screen with everyone so that you guys can see my screen now. So, in this session, like Anupama mentioned, we are going to discuss how one can build a scalable PostgreSQL cluster. And in this, we would be taking you through some of the features of PostgreSQL that helps you create a cluster and also do or also achieve other high availability options that you see in or that rather that you expect in a standard highly available environment. A typical cluster setup that you would want to set up should have at least these features. In general, it should be highly available. That is why you do clustering, so that if one of the node goes down, the other node should be able to take over the load completely. Also, if you want to do any kind of planned outages, for example, if you are applying any patches, or if you want to apply any kind of OS upgrades, so in those cases, you would want to do it at one of the nodes at a time. And that is why people set up high availability clusters so that they can cater to planned and unplanned outages. Apart from high availability and no redundancy, another thing which you would expect from a highly available cluster is load balancing. It is a quite common criteria while choosing high availability setups these days, that you would want the load to be shared between two nodes. So that is another thing. Apart from that, redundancy is of not much useful in a 24 by 7 situations when you have to do an application restart, or if you have to do configuration changes upon failure. Imagine a situation when your database goes down and you are already having a redundancy at the database level. You have another DB node, but before you could use it, you have to point your application to this another DB node and then restart it. So this adds a latency. There is a time gap, and for that time gap your services are not available, and this impacts your business as well. So these are some common criterias, some common highlights, or very standard features expectation that people have from a cluster setup. Now let's talk about PostgreSQL a little bit for all of those people who are new to Postgres and the idea of PostgreSQL. PostgreSQL is talked as the world's most advanced open source database. It is built on top of the same relational theory which forms the basis of other modern day databases like Oracle, DB2, SQL Server, Sybase, and most of them. It has advanced streaming replication feature, as part of which you can stream the changes happening on a master database to the slaves. And this can happen pretty much in real time. You don't have to wait for your changes to be archived. When I say changes, I'm talking about changes which are logged in the wall files or transaction logs, and you don't have to wait for these transaction logs to be archived. It has got rich point-in-time recovery capabilities, which means that you can restore a backup and then you can start rolling forward using the archive logs, and you can stop at a particular time. Let's say at 4 o'clock in the evening, you realize that there was a table which was dropped at 11 a.m. in the morning. So what you can do is you can restore a backup which was taken at 7 p.m. on the previous day and apply the logs and stop the recovery just before 11 a.m., which means you are going to skip the transaction which involved the table drop. And this is why it is called point in time. You are recovering to a particular point on the timeline, and it is a feature which you would see in any of the modern day enterprise class database, and PostgreSQL also has it. It has got multi-version concurrency control, conceptually, which is pretty much similar to Oracle's undo table spaces. And what it does is it creates multiple snapshots of the data. As and when you update a particular row, a new snapshot of that row is created. That is why it is called multi-version. And this helps in catering to concurrent queries. That is why if someone is updating the data, someone else can read that data simultaneously. So readers do not block writers and writers do not block readers, which is pretty much what Oracle undo table spaces achieve. A similar thing is achieved, or a similar phenomenon is achieved in DB2 and SQL Server as well by different mechanism. In DB2, they copy the older snapshots in the log files, whereas in Oracle, they copy the older data in the undo table spaces. One of the things which as a DBA I have faced is you run into issues like running out of log or primary and secondary logs on DB2, because all the older data is being copied into the log files. So there is a limit to what you can achieve, or there is a limit on how much data you can update at a time. Whereas in case of PostgreSQL, the data snapshots are created with the same data blocks. It supports ANSI SQL. It that means that whatever ANSI SQL syntaxes are defined by ANSI, all that is supported by PostgreSQL. And from that, PostgreSQL actually derives its name. Initially, it was called Postgres because it was started from Ingress project. Ingress project, which forms the basis of a lot of modern day databases, including SQL Server, Informix, Ingress itself. That also forms the code base of PostgreSQL fork, and that is why it was called Postgres. And around 1995, they started supporting ANSI SQL, and that is when it was renamed to PostgreSQL. But still, a lot of people, including me, we love the name Postgres for its short term. And when we say Postgres, we are referring to PostgreSQL and few other forks of PostgreSQL which are available in the market. There are no SQL data type support in Postgres, which includes JSON, JSON-B, which was introduced in 9.4. And if you have not watched our video about JSON-B, then I suggest that you go and watch the recent video that we have, the previous Hangout that we did on JSON-B features in 9.4. And there is store data type as well, which allows you to store data in key value pair. Now here is a brief architecture diagram of PostgreSQL, and in this architecture diagram you will realize that a lot of components would resemble other database products that you see in the market. So Fundamentally, like I said, it is based on the same relational concepts. So it supports ACID compliance, and to support that, it has got multi-versioning concurrency control, and it has got wall segments or wall files where it logs every transaction. So whenever you do an update, that update will update data in shared buffer, but all the updates will not be flushed immediately to data files upon commit. This is done so that you get a better performance out of your shared buffers or out of your write queries. And to avoid losing transactions or avoid losing changes, PostgreSQL maintains wall segments. These wall segments capture each and every update, insert, delete, and other modifications in the wall files. And these wall files can be reapplied in case of a crash. So that is how PostgreSQL recovers from a crash. Now, shared buffers are also useful for buffering your data content. So whenever you want to read something, PostgreSQL will not read it directly from the disk. It will first read from the disk and cache that in the shared buffer. And any subsequent request for the same set of data will be catered from the shared buffer. So it optimizes your performance without compromising on the reliability of the database. There is BG Writer, which ensures that shared buffers are being flushed to the data files on a regular basis so that you have free supply of, or rather you have enough supply of free buffers. There is an archiver process which would archive the wall segments, and this wall segment is what is very important to understand here, because these wall segments are useful in point in time recovery, as well as they are useful in doing replication. And if you have not already watched our previous videos on streaming replication, please go and watch them. You will realize how easy and how intuitive it is to set up replication with PostgreSQL. In this session, we are not going to get into details of how you can set up replication. Rather, we are going to see how you can capitalize on the feature of streaming replication and build clusters. But before we go into that, I would like to talk about some of the customers or some of the users of PostgreSQL and Postgres Plus. You can see pretty large companies, pretty well-established names over there: Skype, Instagram, Yahoo, InMobi, AutoZone, NIC in India, Sony Online, State Farm. All these are very well-known, very well-established users of PostgreSQL and Postgres Plus. Let's look at some of the high availability options that you have in PostgreSQL. You have OS level clustering, where you can do OS level clustering, or you can use a separate cluster tool like Red Hat Cluster Suite, or you can use HP Service Guard. The only disadvantage of shared disk cluster in Postgres is there is only one node which is active at a time, which means that you are using only 50% of your capacity. Though it is pretty good for high availability, but it does not do any kind of load sharing. It doesn't load balance your read or write queries. At a time, you're only using 50% of your hardware. And plus, you have to also do some kind of disk level mirroring, which is the case with other shared disk high availability options that you see with with OS level clustering or any other high availability solution which implements database level clustering using shared disk. You need to have some kind of disk redundancy, some kind of parity at the disk level as well. Streaming replication is another way of achieving redundancy or high availability at the database level. Only thing is it does not do auto promotion of the node. When you are using a clustering tool like Red Hat Cluster Suite, it manages the failover automatically. So if your primary node goes down, the secondary node will take over automatically. That does not happen automatically in streaming replication. Streaming replication can only do replication. It doesn't do node promotion. And you can do read queries from the replica. You can fire read queries on the replica, but it does not happen automatically. You you have to connect to the replica separately, or you have to build some logic in your application which would redirect read queries always to the replica. But let's look at some of the next slides and see some very popular architectures that our team has implemented in in our customer base and which we have seen getting popular. We will also be discussing some limitations and some pros and cons of each of these setups. A very basic setup, like what I discussed on the previous slide, is streaming replication, in which case there is no shared disk. It is shared nothing. You have got two setup servers. Each has got their own database and database files. And there is a wall writer process which writes the data or the wall data to the disk, and there is a wall sender which sends the wall records or each change operation to the standby server. Standby server receives all these changes via wall receiver and flushes them on the disk, or applies them on the data on the database. There is no locking which is going to happen because this is not a shared, there is no shared cache here. Each database maintains its own cache. There is no disk contention because each database has its own disk here, and we are replicating operations. It is log level replication or wall level replication, so you are only replicating operations at a time. There is no disk level mirroring which is required because already you have got two set of data, one on primary, another one on secondary. Your standby server can accept the read queries. The only challenge here is you cannot do automated load balancing. You cannot do automated failover. So once primary server goes down, you have to start your application to point to the standby server, and you have to promote the standby server. Plus, you should also build some kind of logic in your application itself so that it redirects the read queries to the standby server. Now, to overcome the challenge with load balancing, you can introduce pgpool, which does the load balancing automatically. So your application connects to pgpool using the same dialect that it uses to connect to PostgreSQL. And pgpool can detect failures, and it can start sending the read queries to the standby server. Sorry, it can start sending all the queries to the standby server. Only thing that it does not do is auto promotion of your standby server. Though it recognizes that master has gone down and it needs to start sending queries to the standby, it does not do promotion of the standby server on its own. So that is one of the challenges that we have seen. Though pgpool has got certain parameters which enables you to use pgpool for doing automated failovers. If you use, there are some parameters of failover command and recovery command and those things. If you are using pgpool and you want to do failovers automated in an automated fashion, you can do that. But we have seen there are certain challenges when you're trying to implement that. In addition to that, here pgpool becomes a single point of failure. So that is a challenge that we have seen, or that is not just a challenge, but also a concern which we have seen. from a lot of customers. To, to do automated failovers, you can use a clustering tool which is provided by Enterprise DB called Failover Manager. It is quite a good tool. Uh, we like it quite a lot. It has an automated way of capturing the heartbeat of primary and standby server. It also does a health check on the database and uses an ICMP heartbeat and keeps a check of the situation of primary and standby servers. And if the primary server goes down, it fails over to the standby server. You can also use a virtual IP. So it has an optional virtual IP concept. So your application always connects to this virtual IP. And if your primary server goes down, standby server will get promoted and the virtual IP will move to the standby server. This way, it ensures that there is no configuration changes required in the application. Only drawback or limitation of this setup is still you have to build the logic of redirecting read queries in the application. You cannot automate that. You cannot do auto load balancing. A similar setup can be implemented with open source components as well. For example, using Pacemaker and CoroSync, you can set up a replication and you can set up continuous heartbeat as well with Pacemaker, and they will ensure that there is a virtual IP which is used for replication instead of using the actual physical IP of the primary server. And once you are doing a kind of switchover, the virtual IP will shift to the new primary, and that will be used by your new secondary for replication. Application will also interact using a virtual IP, which will move over to the primary. Only challenge here is there is no load balancing again. It is just an alternative to using Enterprise DB's failover manager. The only difference is when you're using CoroSync and Pacemaker specifically, you just have to be quite proficient with their setup, and you have to have good knowledge of those products, in addition to having PostgreSQL knowledge. You can also set up a cluster along with pgpool and failover manager. So here what we have done is we have combined two different products to achieve a complete cluster. And this cluster does an automated failover, which is taken care by failover manager. So if my primary goes down, the promotion of secondary or the standby server is taken care by the failover manager from Enterprise DB. And the load balancing of queries is taken care by pgpool. So this solves a lot of your issues, that it does automated failover. Your application configuration need not change in case of a failover, because application always talks to pgpool. Even if your primary server goes down, pgpool knows that there is a second server which can cater to your requests. And the failover is pretty much automated. The promotion is automated. That is managed by failover manager. Only challenge which remains is pgpool still remains to be a single point of failure. To overcome that, you can introduce another pgpool server which is set up using HA configuration. So pgpool has its own high availability setup, which allows pgpool to exchange watchdog with another pgpool server. And if my primary or the first pgpool server goes down, all the operations along with the virtual IP would shift over to the second pgpool server. Now, in this architecture, you can also place the pgpool services on the database itself. This is pretty much similar to the previous architecture that we discussed. Only thing is we are trying to get rid of dependency on pgpool. We are avoiding pgpool being single point of failure. So here what is happening is we are adding another node of pgpool which is talking to the primary pgpool using watchdog, and if primary pgpool goes down, the secondary pgpool will start making connections to primary and standby, and virtual IP will shift over to the second pgpool, and application will continue as it is. If you want to reduce the number of servers, you can host pgpool on the db nodes, as I said earlier. You can scale up further by adding more pgpool and by adding more database nodes. You can add more underlying replicas or standby servers to scale up further by having uh, more, or by this enables you to cater to more read queries basically. You can also have a 3-node cluster like what I was talking earlier on the previous slide. This is what you can achieve. This looks a little complicated. You are hosting pgpool and database on the same node, and there are 2 replicas of your complete server. So there is another pgpool on each of these servers, and there is a watchdog being exchanged between all 3 of them, and there is database level replication going on, and you can set up ppfm or enterprise db failover manager to take care of database level promotions. So that is what you can do with this. It is a little complicated and has more number of processes running on each of your DB server, because pgpool will be making connections to the database, and it will also be accepting connections from the application. So of course there will be more process overhead on the server where pgpool is active, but it is a little more scalable. You can add more nodes because enterprise db's failover manager now supports more than 2 nodes. You can have n number of db servers in a cluster. So wait, I guess I shifted the, yeah. Now when we were talking to our customers and we were implementing these setups, which we discussed on previous slides, we gradually realized that our customers are also using application clusters. They also have a different mechanism for high availability at the application level, which does redundancy as well as it achieves load balancing. A 2 or 3 node JBoss cluster is a very common setup these days, which is talking to a single database or a database cluster, which means it has got 2 level of two databases in that cluster, or more databases in that cluster. So we realized that why don't we combine this high availability with the high availability which we are trying to achieve at the at the database level. So we realized that it makes more sense to push pgpool to the application servers instead of hosting them with db servers, or instead of hosting them on a separate server. Now each application server can have its own pgpool running, and that is what we try to do for our customers quite recently, and it's holding up pretty well now. So this is what we have done, what you see on the screen right now. The application server has a pgpool setup. Another application server has also got pgpool setup. Pgpool takes care of load balancing, and application server, which is running on the same machine as pgpool, talks to pgpool, fires a query, gets a response. It also fires write queries, which goes to the primary and gets replicated to the standby. And database level high availability or database level promotions is managed solely by the failover manager. Now this holds pretty well because it does load balancing, as well as there is no single point of failure. If pgpool server does not work on any of your application nodes, That means that it will stop responding to the application queries, which in turn means that your application will stop responding to the user requests. And most of the load balancers which we have seen these days are smart enough to identify such issues, and they identify that there is something wrong with the application server, and they start sending queries to the second application server since that failure. Now, only issue is pgpool. If there is a service level failure like what I explained earlier, then just because your PG pool has failed, you lose that application server as well. There is no safeguarding, or there is uh, no way that you can get rid of that issue in this architecture. But it is much more scalable. I can add more DB servers now. Now, instead of witness node, I could have actually used a DB node. Now, just I guess I probably should have explained this a little earlier. When you set up failover manager, enterprise DB's failover manager, you can actually set it up with two nodes. But in that case, to maintain the quorum, you need a witness node, which is not hosting a database, but just has a failover manager agent, which just has voting rights, and it makes sure that there is a quorum and there is no split brain situation. And that is one of the reasons why I prefer Failover Manager over a few other clustering tools. Now, instead of this third witness node, you could have also used a DB node. So you can have 3-node database cluster, and there could be two application node cluster, or 3-node application cluster. So it is quite scalable at both the ends. You can add more application servers with more PG pool at the same time without having much process overhead. At the same time, you can add more DB servers which are replicas of the primary. The same setup that I explained on the previous node can be also achieved using Pacemaker. So pretty much what I explained as the previous alternative, you can use Pacemaker and CoroSync to achieve high availability, and they ensure failover is automated, but still you use pgpool for load balancing, and pgpool will be sitting along with your application server. And this is a architecture which you can achieve using open source components. Now, when you're using this Postgres cluster or one of these architectures that we have seen, you you would realize that you can add more standby servers on the go. These standby servers can be added to pgpool configuration as well. So your load balancing is made double or triple on the fly. You can also add these new standby servers in the list of synchronous standby. And when you add these standby servers in the list of synchronous standby, PostgreSQL makes sure that at least two of your servers are always having the same set of data, which means your primary, whatever operations are done on primary, will be replicated to at least one of the standbys before the commit is considered completed. So it is synchronous. At least one of your servers is always is in sync with your primary server. It works in tandem. It works hand in hand with virtualization and provisioning on the fly, which means that if you are having a virtualized environment, you can still use Failover Manager. It is a technology which was used by Enterprise DB and is still being used by Enterprise DB in their own cloud offering called Postgres Plus Cloud Database in Amazon Web Services AWS Cloud. Uh, you can do auto provisioning on your end as well, or you can pretty much automate at least some bit of that provisioning. For example, for someone, what we have done is we take a VM snapshot. We take a VM snapshot of the standby server, which needs change only in the IP address, and then we start the DB service. And after that, the DB has to just go and add details of new DB server in the PG pool, and configure the failover manager nodes. That is all. And you can also add this, like what I explained. The DBA has to add it in the failover manager configuration as well. And this can be done without messing up the cluster. You don't have to shut down your cluster. Your database service is still available while you're adding a new node to PPFM configuration. Only cluster service or the PPFM service would be stopped, and the database service is still up and running, and pgpool will still be doing load balancing between two servers. And if you have already added the third server, it would still be load balancing to the three servers while you are still adding the third server to PPFM configuration. There is no downtime. Now, at Ashnik, our approach is to offer enterprise class solutions using open source and enterprise open source tools. We provide alternative clustering features, those clustering features which has created lock-in for enterprise customers. For example, there is Oracle, or if you are using SQL Server, uh, there are clustering features available from those vendors, and they have created a lock-in for you. Or you are having some kind of performance compromise, or you are having some kind of constraints which you are facing there right now, but you still have to live with them. You don't have to worry now. Ashnik, along with the offerings that we have, we can help you migrate out of such setups. Our primary strength is in providing consulting to build architectures which are custom made, which are tailored for your specific requirements. So if one of these architectures that we discussed today, if you are interested in them, then we can look at them. And if you think that you need something different, we can discuss it out and customize a solution for you. All these solutions that we have discussed today have come out of some or the other customer engagements that we have had, and we do not try to do the same thing for every customer. We try to understand the customer's requirements and implement something accordingly. The consulting and consulting is what we do there, and we also do implementation for customers to help them migrate their databases to Postgres, and that you will be able to do without compromising on availability and recoverability of your current setup. So you don't have to compromise on HA or recovery capabilities of your existing database, and still you can make good out of PostgreSQL. Now, I would open the floor for questions. If you guys have got any questions, let me go back and check. Let me stop the screen share and let me check on the questions. Okay, so here is a question. Yes, the question is, can we have a replication asynchronous as well? Yes, that is completely up to you. You can have synchronous or asynchronous replication. And when you are doing load balancing with pgpool, you can let pgpool decide if it should stop sending the read queries to the replica. Because if your replica is already, if your replica has already you know, if your replica has already gone behind your master server, then you need to stop accepting any more read queries, and that is a configuration which you can decide in pgpool. All right, looks like my colleague has got some issues at in the Hangout. Let me just check that out. Meanwhile, let me just explain. a little more about this whole setup. Uh, so So yeah, so you can provide that. You can also do that. You can also check the lag in replication on your own from a view called pgstat replication. If you want to know more about replication setup and how to set it up and how to monitor it, you can go through PostgreSQL documentation. There is pretty good examples available. You can also check few of our blogs and our past Hangout sessions, where you will find quite a good lot of uh, information on how to set up replication and how we can do these things. There is one more question. What if the third node fails? Yes, so Sandeep has asked if what if the third node fails, and I believe what he means here is he's referring to the witness node. If so, that is what I think. I assume he's referring to the third node as the witness node. If the witness node fails, what happens? So if your witness node fails, since it is not carrying any database, nothing happens to your cluster. The cluster continues as it is. Your primary server remains primary. The virtual IP still remains on the primary server. The secondary server still continues to be secondary server. And if you are using pgpool, even in that case, the primary and secondary roles are not reversed. But if your primary server also goes down in the same duration, then you may have a problem. If you're using pgpool, then that problem may not be that severe, because pgpool may identify the failure and it may start redirecting all the queries to the standby, in which case the read queries can still be catered, because the standby server can still answer to those read queries. Now, since pgpool since pgpool is not being used for promotion, the standby server is not yet promoted. So I think that is what Sandeep was asking, and yes, you may have some problems if your two nodes go down at the same time. But if you want even higher level of resiliency and redundancy, you should have more number of nodes. That is how the recoverability factor works, and that is why we we always, we find that customers enjoy our consulting engagements, because there we advise them to weigh their options of cost versus availability. Now, if you want your database to be 99.99% available, there is we try to work it backwards. How much is the downtime that you can afford, given that your availability requirement is 99.99%? Now, based on that, we would try to advise you what is the level of redundancy that you want. We have worked with a customer where we have set up redundancy at various levels. We have built redundancy using PostgreSQL's streaming replication. We have set up a cluster using Failover Manager. We have set up a logical replication. We have also set up VMware site replication. So there are different ways you can achieve different levels of resiliency. And as part of our consulting engagements, we help you find it out. Yes, it is not possible